Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at simple versus compound interest. So this is the formula for simple interest. It calculates the interest after a certain amount of time, whereas this formula for compound interest tells you how much you have in total after a certain period of time. So for simple interest, if you want to know how much you would have in total, you need to add the interest to the principal, how much you started with. So let's look at the difference between the two using an example. So let's say I invest $1,000 at 10% per annum. So in year one, if the interest was simple interest, you would earn 1,000 times 10 times 1 over 100. You would earn 10% of 1,000, you'd earn $100 in interest. So at the end of year one, you'd have $1,100. Now, for simple interest, you would earn the same amount of interest each year. You'd be going up by $100 each year. We can use the formula at the top if we like. So for year two, 1,000 times 10 times 2 over 100 is 200. We've earned 200 in interest after the second year. We've earned $300 in interest after the third year, and so on. We would have earned $2,000 in interest after 20 years. So for simple interest, the amount of money that you have, the value of your investment, goes up by the same amount each time. We know, however, though, for compound interest, it is an example of exponential growth. The amount you have increases at an increasing rate. So after 1 year with compound interest, you'd still have $1,100. You'd have the same as for simple interest. But what we're going to see is that this will grow a lot quicker. After 2 years, how much would you have with compound interest? Well, you'd have 1,000, the principal, times 1 plus 10 over 100 to the power of 2. See, what's happening with compound interest, you're earning interest on top of the interest. Instead of in year two earning just 10% of the original amount, you're earning 10% of this. So 10% of 1,100 is 110. You'd actually earn $110 in the second year. And then in the third year, the amount of interest you'd earn is 10% of that. So you'd earn $121. So you'd have $1,331 in compound interest. So you can see that you're growing your investment a lot quicker with compound interest. So how much would we have after 20 years? We'd have 1,000 times 1 plus 10 over 100 to the power of 20. It turns out you'd have about $6,728. You would have substantially more with compound interest than simple interest, because for simple interest, your investment grows by the same amount each year. Whereas for compound interest, it increases at an increasing rate. It went up by 100 in the first year, then 110 in the second, and 121 in the third, and so on. The difference between the amount you have after each year is itself increasing. So for simple interest, if you were to graph how much money you have, it would be linear, because you're going up by the same amount each time. For compound interest, it's exponential. It gets really big really quickly. All right, let's now look at another example involving the link between simple and compound interest. So a bank offers 5% per annum interest compounded annually. If I invest $4,000 for 10 years, what is the rate of simple interest required to attain the same result? So the idea here is that if the interest was compounded annually, I'd end up with substantially more money than if it were simple interest. So I would need a much higher rate for simple interest than for compound interest to earn the same amount of money. So how much money would I have if interest were compounded annually? Well, we can just use the compound interest formula. The amount you would have is P, the principal, how much you started with, times 1 plus r over 100. R is 5 because it's 5% per annum. And then that's going to be to the power of 10 because you're compounding 10 times in 10 years. So putting that on our calculator, we would have about $6,515.58. That's how much we'd have if interest were compounded annually. So we know that we would have substantially less money if it was simple interest. We're going to need a higher rate. So how do we find the rate required using simple interest? Well, we're just going to use the formula that was on the screen last time. So the simple interest formula is I equals PRT over 100, P, R, and T having the same meaning as in compound interest. So P is the principal, how much you start with, R the rate, T the time, I the interest. So the idea here is if I want to attain the same result, if I want to earn the same amount of interest, that means I want to earn $2,515.58. That's how much interest we earned with compound interest. 6,515.58 minus 4,000 gives us that. So we know the interest we want to earn. We know the principal, that's just 4,000. That's just what we started with. What we want to do is find R. We know that T is 10 years, so we'll substitute in this. So here we have an equation that has just one variable, R. We can rearrange and solve for R. Let's undo everything that's been done to R. So the first thing I'm going to do is times each side by 100. That'll get rid of the divide 100. Note also that 4,000 times 10 is 40,000. So we've got this equals 40,000 times R. So all we need to do now to get R by itself is divide each side by 40,000. So putting that on our calculator, 251,558 divided by 40,000, we get that R is approximately 6.3%. I've just rounded to one decimal place. So because it was per annum, interest compounded per annum, because the original question was per annum, so too our answer is per annum. So to get this amount of interest, $2,515.58, you only need 5% if compounded annually, but you need 6.3% if it were simple interest. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.